Okay, so now I am going to tell you that how to find out uh, the residuals. Okay, how to find out the residuals. You can see that suppose you have seen earlier that this is your X value, food intake, and milk yield, this is your Y value, okay, or the dependent variable. Now you are unable to find out the true line because you are unable, it is infeasible to find out it is infeasible to take the data from the population. You can collect the samples, not population. So the regression equation that you have found out, y is equal to 0.8 plus 0.65 into x1, this is essentially based on the sample. Okay, so this is actually the equation of the estimated line. Okay, so you will find the estimated value based on this equation. Okay, so you can, if you want to find out the estimated value for the, suppose for the food intake 4, then you put here 4. If you put here 4, then 4 into 0.65 plus 0.8, you calculate the value of y. This will be your estimated value for sample number 1. Okay, for suppose cow number 1, this will be your estimated value. Okay, so now your actual or observed value is 3. So the difference between the 3, suppose it has come out to be 4. So what will be the difference? 4 minus 3 is equal to 1. Okay, so this will be your residual. Okay, this difference will be actually your residual. Okay, and this is actually known as residual. Okay, similarly, if you, in place of x, if you put 6, you will get some values. Okay, that will be the estimated value for sample 2 or cow number 2, and this is your observed value. So if you find out the difference, then it will be another residual, okay, for sample number 2. Okay, so these residuals you can very easily calculate, but you cannot calculate your error terms because there is obviously the observed values are there, but the true values based on the population you cannot calculate because you don't know the value of the true line. Okay, you don't know the value of the true line which is based on population. So that's why you are also unable to find out the error terms. Okay, so this is the fundamental thing of the simple linear regression. Okay, and similarly in case of multiple linear regression also the concept is same. Okay, for the multiple linear regression also the concept is same in terms of the residuals and error, the concept is same. Now I am going to discuss you some concepts, some very important concepts like how to determine the direction and the strength of the regression. Okay, so there are 4 terminologies that you will find. whenever you will be dealing with regression, you will be finding four different terminologies. One is covariance, another is correlation, which is denoted by R, or it is also termed as correlation coefficient. You will find another term that is known as R square, or the coefficient of determination. Okay, and then finally another term you will find which is known as adjusted R square. Okay, so first let me talk about what is covariance. Covariance is a measure of how two variables are changing together. Okay, covariance is a measure of how much two random variables vary together. It's similar to variance, but where variance tell you how a single variable varies, covariance tell you how two variables vary together. And the covariance, the expression of covariance is given by this. Okay, there is a formula. Okay, based on this, you can calculate your covariance. Now, what is correlation? Correlation is also like covariance, but it is actually standard covariance or normalized covariance. Because why it is how it is normalized? It is, you can see that the covariance is actually divided by the standard deviation. That means it is being normalized. So this is actually the formula for correlation, or alternatively you can see that this is actually the formula for the correlation. And the correlation, the upper bound and lower bound of the correlation is from -1 to +1. Okay, if you find that the correlation is 1, it means perfectly positively correlated. Okay, if you find that correlation is -1, it means it is perfectly negatively correlated. And if you find that correlation is 0, that means being independent. That means X and Y are not dependent on each other. Okay, perfectly, there is absolutely no relationship. And if you find that correlation is 1, that means this is perfectly positively correlation is there, and they are in the same direction. And correlation negatively 1, there is absolute relationship, negatively relationship in between the two variables, but they are negatively correlated. Okay, now you can see the diagrams. This is the concept of correlation of xy is equal to 1. You can see that perfectly correlated, you are getting a straight line, perfectly correlated. Okay, if correlation is x is -1, this is also perfectly correlated, but you can see that it is in the negative direction. Okay, this is not this side. Okay, this is the side of -y. Okay, and if you find a very weak relation, okay, that means usually you will not find that no correlation is there. It is, you won't find. If you randomly select any two variables, obviously there will be at least some amount of correlation will be definitely there. Okay, but it may be very weak. So in case of weak correlation, you can see that this is positively weak correlation, and this is negative weak correlation. Okay, you can see that the data are scattered, very scattered. It is not, the data are not making any kind of the straight line is not there. Okay, so these things are actually there. Okay, so so this is all about the correlation. Okay, so now I will discuss about the one thing you should remember, that actually first let me tell you whenever I am discussing the correlation, covariance, covariance, it basically, covariance indicates the direction of the linear relationship between the variables. Okay, that means whether the variable, suppose you have x and y, these two variables, x is independent variable and y is dependent variable. So covariance will only tell you that how they change together. That means suppose if you increase x, whether y will also increase or y will decrease. Covariance will only tell you the direction. Okay, but covariance will not tell you the strength of the relationship. That means how close they are related to each other. Okay, in which degree they vary. Okay, or sorry, they change actually. So that the strength of the relationship, that will not be determined by the covariance. But whenever you talk about correlation, suppose you have found the value of the correlation coefficient or the R. Okay, so you know that the value could be, you are standardizing it, so the value will be -1 to +1. Okay, and you can not only understand the strength, I mean the direction of the linear relationship, because from the minus value or the plus value, you can obviously, you can very easily understand that the direction of the relationship, that it can be understood very easily, just like covariance. But it will also tell you the strength of the relationship. Okay, for example, if you find, suppose x and y, the relation, the R value is suppose 0 plus 0.9. So what you can understand? You can understand two things. One is that x, the relationship between x and y, it is very strong because you are having 0.90 value or 0.95 value, which is very close to 1. So the relationship is very strong. And also you can understand the relationship is towards the positive direction. That means if there is any change in x, in the increase in x, you will also see the increase in y. Okay, so this is the fundamental thing of covariance and correlation. Now we will talk about R square. Okay, R square, it basically it is also known as coefficient of determination. R means correlation coefficient, but R squared means coefficient of determination. Okay, now you very often you will find that we find the value of R squared. The R square value, it is from 0 to 1. Okay, because actually you R square you actually express in terms of percentage. Okay, so now let's take a look at that, what is the concept of R square. Okay, but in order to understand the concept of R square, okay, we first must know that the concept of variance. Okay, you can see that there are three different types of variance. One is specific variance, another is error variance, then there is common variance. What is specific variance? Specific variance is variance unique to the variable itself. Error variance, this variance is due to measurement error or some random or some unknown source. Okay, and common variance is variance that a variable shares with other variables in a matrix. So the total variance is given by common variance plus specific variance plus error variance. Okay, so what is this thing? Let me explain you. Suppose you think about this data. Okay, this earlier data. Okay, so what you can see there, you can see that you can very easily calculate the variance of the data of the y variable. Okay, there are 4 samples you have taken for y, so you can calculate the mean. Okay, 3 plus 5.5 plus 6.5 plus 9, you can calculate the, divide it by 4, so you can calculate the mean. Okay, it is no problem. Then if you, from the mean, if you subtract the data of each and every sample, and if you make it square, okay, then you will be getting the and if you divide it by n, or the suppose, or the sample 4, okay, so you will be getting the, it has been closed, I'm reopening it. So you will be getting the variance. Okay, the variance, you very easily you can understand that how to find out the variance. Okay, so this variance will have, suppose you have found the variance is suppose 10. Okay, so this variance will have, this is actually known as the variance that you are finding. That variance is actually known as the that variance is actually let me share the screen. Yes, so that variance is actually known as the total variance. Okay, the variance in this data that you will see, that is actually the total variance. Okay, so inside the total variance, there you will have some specific variance. There inside this variance you will have some specific variance. Specific variance means that variation is only because of this y variable itself, milk yield. Okay, this component will be there. There will be another component which is error variance, that we cannot measure. Due to some random error, there will be some error variance. Okay, and there will be some variance which will be known as common variance. Common variance means that variance is also applicable for your independent variable, okay, or this variable. And that's why this common, because of this common variance, this independent variable is actually able to explain the variable y. That is actually known as the common variance. Okay, because suppose you are increasing food yield and also milk yield also it is increasing, so there is some variation of the food. Okay, so the, and there is some variation in the milk yield, so there is some common part. That's why the food yield, because of the increase in food yield or food intake, the milk yield, it is also being increased. Okay, so that is actually known as the common variance, because common variance actually explains, it is quite natural that common variance will be explaining the reason of change or reason of variation in the y variable because of the x variable or the because of the independent variable. So that is known as the common variance. Okay, now if you think about the r square, okay, suppose this is the best fitted line. Okay, I have previously told you the definition of best fitted line. What is known as the best fitted line? Best fitted line means where the variation will be less, okay, or least. That means the variation for the best fitted line that you are capable to see, this variation is only because of the unavoidable variation. Okay, that means only because of the error variance or the unique variation itself that you are capable to see. Okay, which is actually unavoidable variance, or you can see that this is also the, you know, the uncommon variance. Okay, the error altogether, the the error variance and the unique variance, you can term it as the uncommon variance. Okay, so the variance that you are able to see, that is here, it is the because of only this variance. Okay, now you consider the minimum, the mean value or the mean variance. What is mean variance? Mean variance is nothing but suppose I have told you that you have found out the y value. Okay, if you calculate the mean, okay, and if you calculate the subsequently the variance, that is actually known as the the variance due to the mean. When you are calculating the mean depending upon the mean, that is actually known as the mean variance. Okay, so you are actually basically in R square, in case of R square, you are basically comparing these two variants. Okay, that how much your best fitted line, the variance of your best fitted line, how much it is less variance than your worst fitting line, or than the mean variance. Okay, that you are actually trying to find out. Okay, here suppose the R square value, you can see that in terms of percentage they are calculating, that's why they have divided it by variance of mean, and the R square value they are getting 0.81, that means 81%. Okay, so that means the relationship, it accounts for 81% of the variation. Okay, so these two lines are very important. You can understand that variance of y in the best fitted line is unavoidable. Okay, so the rest of the variance found in y from the average can be explained by x. Okay, so what I am trying to say, when suppose this line, okay, based on the mean, okay, this has got some variance, it has got the common variance and as well as uncommon variance. Okay, but when you have when you have got the value of the, when you are considering this best fitted line, you are having only the common variance, you don't have the uncommon variances, only the common variances you are having. Okay, sorry, only the uncommon variances you are having, the common variances are not there. So here you are considering common plus uncommon, and here you are considering only the uncommon, because there is only uncommon, it represents the uncommon variance. So common plus uncommon minus uncommon, common variance plus uncommon variance, okay, minus here it is uncommon variance. So uncommon variance and uncommon variance will be cancelled. So only there will be the common variance. So that's why if you take a difference between these two things, only common variance will be there. You will be getting only the common variance, which is actually explaining by x. So basically with the help of the R squared method, you can segregate your common variance, because your mean, this line is telling you the common plus uncommon, and this line is telling only the uncommon. Okay, so you can segregate your common out of the uncommon things. Okay, So the common variances you can segregate, and that variance is actually, it is being explained by your independent variable x. Okay, so this is your R square value. Okay, so if R square value is high, that means there is a very strong relationship between your independent variable and dependent variable. Okay, so now there is another concept. This is the final concept of adjusted R square. Okay, I have already told you the concept of R square. Okay, now why adjusted R square? Because suppose if you increase your sample size, okay, suppose you have taken 4 samples for y. Now suppose instead of 4 samples there, you have taken 8 samples, you have taken suppose 16 samples or 20 samples. Okay, so if this thing happens, okay, so then what will be then, if if you increase your sample size, okay, then what will happen automatically, there is a chance that your R square value will also increase. Why? Because I have already told you earlier that there is a chance that arbitrarily or randomly, if you take any 2 variables, okay, there will be a relationship between that. Okay, so there is a possibility that if you take if you increase the sample size, the R square, there will be a tendency, automatic tendency, that your R square value will go up. That is quite based on the formula for R square. Okay, so that's why the concept of adjusted R square has come, because adjusted R square, even if you increase your sample size, because sample size, I have already told you that our value of R square is affected by or influenced by the sample size. But in case of adjusted R square, the value of the adjusted R square is not actually influenced by the sample size. Okay, so even if you increase the adjusted your sample size, adjusted R square will not increase by chance. Adjusted R square will only increase, okay, if it actually, if your the newly added values, if it really improves your model in terms of the relationship, okay, then only you will find higher adjusted R square, or your adjusted R square value will increase. Otherwise it may, if you increase the sample size, and if it is by chance, if there is no relationship at all, then adjusted R square, it will never increase. It may decrease even, but it will not increase. Okay, so that's why the adjusted R square concept has come. Okay, so finally speaking, these two if I want to summarize all these concepts, then covariance is a concept where you can only see the direction of the variables. Okay, a correlation or R or correlation coefficient, the value will be from -1 to +1. Using that, you can not only identify the direction of the relationship between the variables, but also you can identify the strength of the relationship. Using the R square, you can, in terms of percentage, you can identify the strength of the relationship. Okay, but adjusted R square is better than R square, because it will help you. Instead of R square, you will actually use adjusted R square to use in your research work, because adjusted R square will actually help you to identify that how strong your relationship is, and there will be no biasness, or there will be no there will be, it will not show you any kind of false relationship. Okay, that is there, and but that kind of thing might happen in case of R square due to the increase in sample size. Okay, so this is the basic concepts of the linear, I mean the regression, and in the next class we will try to focus on the some parts of the you know the logistic regression, and also uh, what is maximum likelihood estimation, that we will also try to explain. Basically here we have used, you have seen that least square method we have used uh, for to determine how to calculate the coefficient or the intercept, but even if we use the maximum likelihood estimation, in this case we will get the same thing. Okay, same results. Okay, so now I'm going to take the attendance. I'm going to stop the recording.